10 minutes ago, you were somewhere else entirely. A different world, different rules, different versions of you. And then your alarm went off. And within 10 minutes, it was gone. Not partially gone, not blurry, completely, totally gone. You try to remember a face, a place, a feeling. But the harder you reach for it, the faster it disappears. Why does the most vivid experience your brain creates every single night vanish the moment you open your eyes? The answer reveals something extraordinary about how your memory actually works. And today, we're going inside it. Before we understand why dreams disappear, we need to understand what they actually are. Most people think dreams are random, just noise from a sleeping brain. That is not what science shows. Dreams happen almost exclusively during one specific sleep stage, called REM, sleep. Rapid eye movement. During REM, your brain becomes almost as active as when you are fully awake. Neurons firing, stories being constructed, emotions being processed, a full internal world being built from nothing, and you experience none of it as strange. In the dream, everything feels completely real. That is how powerful the dreaming brain is. For a memory to stick, to become something you can recall later, it has to go through a process called memory consolidation. This process requires two things working together: the hippocampus, your brain's memory recording center, and the prefrontal cortex, the part of your brain responsible for logic, attention, and conscious thought. During waking hours, these two regions work constantly together. An experience happens, the hippocampus records it, the prefrontal cortex tags it as important. The memory gets filed, but during REM sleep, during dreaming, something critical changes. The prefrontal cortex goes almost completely quiet, not asleep, not broken, intentionally offline. And without the prefrontal cortex active, there is no one tagging the dream as important. The hippocampus records the dream, but without the tag, it never makes it to long-term storage. And when you wake up, within minutes, the fragments begin dissolving. But why does the prefrontal cortex go offline in the first place? The answer is chemical. During waking hours, your brain is flooded with a chemical called norepinephrine. It keeps you alert, focused, able to form and retain memories. But during REM sleep, norepinephrine production shuts down almost completely. Scientists believe this chemical shutdown is intentional. Without norepinephrine, the brain enters a different processing mode entirely. More creative, more associative, less logical. This is why dreams feel so strange, yet so real at the same time. But wait, some dreams are remembered, at least briefly. How does that happen if the system is designed to forget?
It was so real.
Researchers found two conditions that allow dream memories to survive. The first, waking up directly from REM sleep. When you wake mid-REM, the prefrontal cortex comes back online, while the dream imagery is still present. For a few seconds, maybe minutes, it can tag some of what it finds. That is why dreams remembered immediately after waking fade so fast. The window is seconds, not minutes. The second condition may use strong emotional content during the dream. The amygdala, your brain's emotional center, remains active even during REM sleep. When a dream triggers intense fear, joy, or grief, the amygdala signals urgency, and that emotional urgency can partially override the norepinephrine shutdown. This is why your most vivid, most emotional dreams are the ones you remember. Humans have been confused by dreams for as long as we have existed. Ancient Egyptians believed dreams were messages from the gods. They built temples specifically designed for dream incubation. Ancient Greeks had the same belief. Entire cities would travel to dream temples called Asclepia, believing the god of medicine would heal them through their dreams. For most of human history, forgetting a dream wasn't a scientific question. It was a spiritual failure, a missed message from the divine. It wasn't until 1953 that science finally caught up. Two researchers, Eugene Aserinsky and Nathaniel Kleitman, discovered REM sleep by accident while studying infant sleep patterns. They noticed the eyes moving rapidly under closed lids during certain sleep stages. And when they woke participants during this stage, almost everyone reported vivid, detailed dreams. That one discovery opened the entire modern science of sleep. Now here is the part that changes everything. What if forgetting dreams isn't a flaw? What if it's exactly what your brain intends to do? Researcher Francis Crick, co-discoverer of DNA, proposed a theory called reverse learning. His idea: dreams exist to clear out unnecessary neural connections that built up during the day, like defragmenting a hard drive, removing the junk so the system runs cleaner. In this model, remembering the dream would actually defeat its purpose. A second theory comes from Matthew Walker, one of the world's leading sleep scientists. He proposes that REM sleep specifically helps process emotional memories, separating the emotion from the event. So you remember what happened, but the raw pain or fear attached to it becomes softer. REM sleep as emotional therapy, running every single night, without your knowledge. So is there any way to remember more of your dreams? Researchers say yes, with specific conditions. The first, don't move immediately when you wake up. Movement triggers full wakefulness, which accelerates norepinephrine return, which erases the remaining dream fragments faster. Stay still. Keep your eyes closed, let the dream surface on its own. The second, write it down immediately, even a single word, a color, a feeling. Writing triggers the prefrontal cortex to actively search for fragments. The third, wake up naturally when possible, without an alarm. Natural waking is more likely to happen mid-REM, preserving the dream window longer. So the next time you wake up reaching for a dream that's already gone, remember what was actually happening inside your brain all night. A chemical shutdown designed to free your brain from logic. A prefrontal cortex intentionally taken offline so something deeper could run. An emotional processing system quietly doing therapy on your hardest memories. And a forgetting system so efficient that by the time you are fully awake, the evidence is already gone. You don't remember your dreams because your brain decided they weren't worth keeping. Not because the dream didn't matter. Because it already did its job while you were sleeping. Your brain was working, you just weren't watching. Subscribe to QUREVO, because next week we ask another question hiding inside the ordinary. One you've lived with your entire life and never thought to ask.